Hey there, friends of mathematics. Today we're going to start our first video in our Math 105 series, and we're going to start in section 1.1, and the question is, what is a function? And all we can say about a function is a function is a rule that assigns each input exactly one output value. Now, I know that this seems amorphous and weird, but we're going to do some examples and we're going to get there. There are 4 ways to describe functions. And at the University of Michigan, we refer to this as the rule of 4. And over the entire semester, we're going to be focusing on these 4 things. Now, some of which you know and love. And I think we can probably start out with that. We'll start out with formulas. What we have is some function notation. I can say that y equals f of x, and we can have 3x squared minus 1. Now, if I put a input in, an x value, say I'll do f of 2, there should only be one thing that ever comes out of this rule. And so when I put 2 in, we get 3 times 2 squared minus 1, and that seems like a glorious 11 to me. Good? Put 2 in, only one thing comes out. If I put negative 2 in, 3 negative 2 squared minus 1, we're still going to get that joyous 11. And that's okay, because as long as I assign to each input exactly one output value. So we can say that x, or that y, is a function of x. So formulas are certainly one way of making things. I could certainly make a table. If I made some t values and some w values, and let's say we have 0, 1, 3, 4, and maybe t, the unit here, is days. I don't know what the problem is going to involve. And W, maybe this will be in pounds. Maybe W stands for weight. And we'll say 3, 2, 3, and 7. Good? Maybe this is on a certain day the number of pounds of food I feed an animal. And the question is W a function of t? For each t value, do I get only one w value back? And the answer here is yes. When t is 0, I return 3. When t is 1, I return 2. When t is 3, I return 3. When t is 4, I return 7. This is great. But I'm going to flip this a little bit. Is t a function of w? And now what we're saying, I'm not caring about causality here. All I'm thinking about is my rule. For each w value is assigned to one and only one t. When w is 2, I get sent to 1. Great, that seems to check out. And when w is 7, I get sent to 4. But there's a problem. When w is 3, it doesn't send to uniquely one value. It sends to t equals 0 and t equals 3. When I input when I input 3 pounds, that occurred on day 0 and on day 3. T is not a function of w. Okay, so that's formulas. Here's tables. I think the third way we can envision functions is some sort of graph. And I'm going to use this exact same data set here. I'm going to have a w-axis, I'm going to have a t-axis, and we had 0, 3, and we had 1, 2, and we had 3, 3, and we had 4, 7. I think I'm going to have to break off the charts. Here we go. That's 4, 7. Now, imagine I had an additional value on this table. Let's put in something like 5 and... Let's put in something like 3 and 4. What's going to happen graphically? If I go to 3 and I go 4 here, this is not a function anymore. And what we can say is that a function must pass the vertical line test. Namely, that whenever I have a graph of a function, if I make a vertical line and it crosses twice, it is not a function at all. We have one last thing to talk about, a verbal or written description of a function. So we talk about our fourth way of describing functions, written or verbal functions. And we have to keep in mind that a function, the main idea here is that we're dealing with a rule. Each input gets only one output. This one is good, and this is bad if I have an input and it goes to two different things. So, not a function over here. That one's the function. And I'm just looking at a rule, and I can make rules. So let's say is your favorite color a function of your name? And I think here, presumably, yes. Each person has only one favorite color. You know, actually, I don't know if this is a function or not. My daughter, Ren, is 7, and you ask her her favorite color. She might say that it's blue, but she might also say that it's pink. And so she might have killed function. But let's go for a different verbal example. Your name, or your zip code, is a function of your name. And by zip code, I'm talking about where your current mailing address is. Not where your parents are, where you vacation. I don't care. If you're vacationing, you have a zip code as long as you're in the US. But so, and I think this is a function. You put one name in, there's only one place that that person can be in. Yes, a function. Each person can only be in one place. There's one last one that I'm going to talk about, though, and I'm going to say, is your name a function of your zip code? And this, I think, is very clear that the answer here is no. If I give a zip code, there's going to be a bunch of names that come out, of which yours is one. But when I assign to each zip code, I get more than one name. This is not a function.